This is proofs involving congruent triangles, problem type 5, part 3. We concluded that these two triangles here, ABD, let me trace that one more again, that is ABD, is congruent to triangle CDB. And we did that by showing that first off, the toes, if you will, of the two overlapping triangles were congruent. That's angles 2 and 3. So there's where a pair of angles. And then the sides, the overlapping sides, DB are congruent to DB. It's a pair of sides. And then to get the heels, we had to show that angle B consisted of angles 1 and 2. Angle D consists of 3 and 4. But because 1 and 4 are congruent, we replaced 4 with 1, and we replaced 2 with 3. The reason why we can do this is because of steps 1 and 2. That's called substitution property. So if you look very carefully, here we have measures of angle 1 and 2. Here we have measures of angle 1 and 2. Since those two are congruent, we can say B and D are congruent, and that's what we did in line 7. And in line 7, we said B and D are congruent by the substitution property using lines 4 and 6. And that gives us our third set of angles. Therefore, the triangles are congruent by angle, side, angle, and the steps would be steps 1, step 3, and step 7. Step 1, step 3, and step 7. So once again, to recap, what we did here is we have this triangle ABD. Now congruent to this triangle CDB. And the reason was because first off the toes were equal, 2 and 3, and then the sides were equal because of reflexive, and then the heels were equal because of angle addition property, and then substitution, so they were congruent by angle, side, angle.